A unit vector is a vector that has a magnitude of 1, which means a length of 1, and points in a particular direction. Unit vectors are very useful in physics as they help us denote exactly what direction the vector is in. Your textbook talks about 2 particular unit vectors, but I wanted to give you the more general picture and give you all 3 common unit vectors. The common unit vectors, as you can see on this graph here, are I hat, j hat, and k hat. Commonly, as they're written rather than typed, you'll write them as I with a little hat on it. And that's why they're called I hat, j hat, and k hat. So I hat is a unit vector, which means it has a length of 1 that points in the positive x direction. J hat is a unit vector that points in the positive y direction. And k hat is a unit vector that points in the positive z direction. In AP Physics, we will spend some time looking at 3-dimensional movement and 3-dimensional things rather than only 2-dimensional. Commonly, we may denote a vector with unit vector notation rather than giving its length and its angle. And so we're going to look at an example of that. I have this vector A here, and A has a certain length at a certain angle, but it also has an x component and a y component. If I wanted to write A in its unit vector notation, I would say that A is equal to ax I hat plus ay j hat. It has no length in the k direction and the z direction, so there's no k hat term. Making this maybe a little bit more concrete, let's say that this x component was 2 units and this y component was 3 units. Heck, let's put units on there. Let's say meters. 2 meters and 3 meters. So I could write that A is equal to 2I hat plus 3J hat meters. You can also write it as 2 meters I hat plus 3 meters J hat. The units can go outside at the end or in each term. This becomes a pretty easy and convenient way for notating vectors. So let's look at an example. We're given 2 vectors here. A is 4I hat minus 3J hat plus 1K hat, all in meters. B is negative 1I hat plus 1J hat plus 4K hat, all in meters. It asks us to find, in unit vector notation, A plus B, A minus B, and a third vector C such that A minus B plus Z equals 0. Hopefully you'll find through this example that working in unit vector notation makes things fairly easy, which is really nice. It's not too often that we can get things being... Okay, so let's get started with this example problem. We know that when we add vectors, we add their components. We add the x components together and we add the y components together. So for part A here, A plus B, we're going to add together the x components. Well, it's nice because we know which ones the x components are. They're the ones that have the I hats after them. So 4 meters plus negative 1 meters gets us 3 meters in the I hat direction. I'm going to put the units at the end, that's why I didn't write meters yet. In the y direction, we have negative 3 plus 1, so negative 2j hat. And in the z direction, we have 1 plus 4 plus 5k hat. I put parentheses around the whole thing and I put the meters at the end. It's a lot less writing that way, so I tend to default to that method. part B, when we subtract vectors, we basically just add the two vectors making B negative, or you could think of it as subtracting components, which is so much easier in my opinion. So 4 minus negative 1 gives me 5I hat. Negative 3 minus 1 gives me negative 4J hat. And 1 minus 4 gives me negative 3K hat. Again in meters. The last part, part C, says to find another vector, C, such that A minus B plus C equals 0. Well, A minus B, we already know what that vector is. That's 5I hat minus 4J hat minus 3K hat. If I wanted to add something to that to make it equal to 0, I would just add the opposite. 5 minus 5 would equal 0. Negative 4 plus 4 would equal 0. Negative 3 plus 3 would equal 0. So there's my vector C. We will use unit vector notation all year long to help us denote vectors, and hopefully you will find it to be a simple way to denote vectors. It makes it easy to do a lot of math.